So, grade 7 girls, let us continue plate tectonics. So, yesterday, briefly, I will tell you, I have shown you a map where all of the Asia or Africa or all the continents were very, very close to each other. They were almost attached to each other, right? But later on, gradually we have seen that as millions of years passed, these, because of erosion, because of many factors, how these continents, they got separated and the ocean is flowing in between. We have Red Sea, we have Pacific, we have Atlantic, all these oceans. So now they said South American and African plate boundary showing the mid-Atlantic ridge. The ridge, it's showing the mid-Atlantic ridge here. Scientists realized long ago that Earth crust was divided into moving plates and that the continents moved when these plates moved. Later on, these scientists, they realized that the crust were divided into moving plates, and when these plates move, the continents also, they move.
Welcome to the lesson, Plate Tectonics, where you will learn about the movement of the continents and the powerful forces that are constantly changing Earth's surface. The vocabulary words for this lesson are Scientists realized long ago that Earth's crust was divided into moving plates, and that the continents moved when these plates moved. They couldn't figure out why the plates moved.
Okay, exactly. They imagine that the plates, the continents are moving when the plates are moving, but they couldn't find an answer that why do these plates move?
What is pushing or pulling the plates? The answer lies deep within the planet. The center of Earth is extremely hot. The heat from within Earth's core drives powerful currents within the mantle. These currents push and pull the plates, resulting in massive changes on the surface.
Okay, now so what he's saying here, he's saying that, of course, you know the layers of Earth, compositional layers of Earth. When I'm talking about compositional layers of Earth, you know that we have core, okay? Now this core, we have inner and outer. This is liquid, this is solid, the inner is solid, the outer is liquid. Okay, these currents which are, they are flowing, and they have lot of pressure there deep inside. So these currents, they push and pull the plates, and that's why they push and pull the plates of maybe the mantle, and that goes and push the plates of Earth crust, and that push and pull of the plates, they result in a massive change. You see a massive change on the surface of the Earth.
These changes can be seen in the movements of the continents and the creation of different types of landforms along the boundaries of the plates.
Give me a moment.
The theory of plate tectonics not only explains the movement of the continents, but also shows how Earth's crust is constantly renewed. New seafloor is being created continuously.
Now here they have shown in the map, okay, the pink 0 to 2, 2 to 5. This map, it shows the age of the rock. So the oldest one are the dark blue ones, and they say that every time the new floor is created, new seafloor is created, which has continuously, it changes continuously because of magma. As I told you, the inner core and the outer core is pushing and pulling the mantle, and mantle has magma inside, and that magma is forced to the surface through the ocean ridges, and that's why the new seafloor is being created continuously.
as magma is forced to the surface through ocean ridges. The rock closest to these ridges is younger, and rock that is farther away is older. On this map, you can see where the mid-ocean ridges are located. The blue and gray areas are older. Can you tell which colors are newer rocks? The newer rock is forming along the plate boundaries, such as the mid-ocean ridges. This newer rock is colored orange and red.
You can see that orange and red color are the newer rocks, and the blue and the dark blue are the old rocks.
Tectonic plates interact in several different ways along their boundaries.
So girls, the main theme, the main question to yourself is how the tectonic plates occur. So I have told you very clearly that remember that inner and outer core pull and push and cause some, disturbances, and that travels to the magma or to the mantle, and that in turn push and pull and create some, create some movement in the plates on the earth crust. So tectonic plates, they say they interact in several different ways along their boundaries. We're gonna see those, like it's called as convergent. These are the major vocabulary words: convergent, divergent, and transform.
At a convergent boundary, two plates are moving towards each other. When they collide, two things can happen. In one case, the edges of the two plates crumple upwards, forming mountains. In the other case, one plate...
See, simple they are saying here that, like we say, how do mountain forms? You have the simple plain earth crust and you have simple plain earth crust. When they merge into each other, they come into each other. Either they form mountains, okay, either they form mountains, and in other case, one plate is forced to move under the another. Like example, this layer goes under the other. Some, they just, they form mountains this way. They go up. And in some, they go layer upon layer and they merge into each other, layer upon layer. They're forced to move under the another one. That is called as convergent. In convergent, you will see that both of the, again, I'm going to play it so that you hear it.
At a convergent boundary, two plates are moving towards each other. When they collide, two things can happen. In one case, the edges of the two plates crumple upwards, forming mountains. In the other case, one plate is forced to move under the other. As the plate is forced downward, it melts, producing liquid magma that rises to the surface.
Okay. Now, I told you there are two conditions. Okay, there are two conditions. In one condition, it forms a mountains by colliding with each other. Okay, it forms a mountain. In the other condition, it goes under the another layer. So this, what happened to this layer? This, because it goes under, it goes and mixed with magma. It melts. It melts because it goes and mixed with magma. So this is why volcanoes often form along convergent boundaries. This is why the volcanoes form convergent boundaries.
Along a divergent boundary, two plates are moving away from each other. Here, magma...
So what is the main difference between convergent and divergent? In convergent, the plates are coming and, banging each other, bouncing each other. When I'm talking about divergent, the plates are moving far away from each other. This is the major difference between convergent and divergent. You know that on the road when you are going, okay, on the road when you're going straight, you say that we get a divergent here, we get a different path away from this road, we have a divergent here. So divergent means it's the plates are moving away from each other, and convergent means they are coming they're coming and joining together.
Along a divergent boundary, two plates are moving away from each other. Here, magma pushes up from below, cools, and forms new rock on the surface. It's along this type of boundary that seafloor spreading happens. A transform boundary occurs when two plates slide past one another. Because the rocks cannot glide smoothly, stress may build up along these boundaries, and the energy is suddenly released in the form of an earthquake.
So this is how the earthquake happened. They come and they slide over each other. They cannot even go inside. And finally they are breaking and causes earthquake.
Okay.
A transform boundary occurs when two plates slide past one another. Because the rocks cannot glide smoothly, stress may build up along these boundaries, and the energy is suddenly released in the form of an earthquake. Click a location to learn more about the boundary type.
As I told you, when you see the diversion, that means it is moving away from each other. When I say convergent, it is coming close to each other. When I say transfer, that causes earthquake.
Seafloor spreading between the Nazca Plate and the Pacific Plate pushes these two plates away from each other. As magma pushes towards the surface, a ridge of new rock is forming. Explorers have discovered hot springs called black smokers along the ridge. The Nazca Plate slams head-on into the South American Plate, causing a convergent boundary. As the plates collide, the Nazca Plate dives under the South American Plate, causing the edge of South America to rise. The result is the towering Andes Mountains along the coasts of Peru and Chile.
Okay, so Peru and Chile, these coasts are because of convergent boundaries. Okay, they come and they form mountains.
The Pacific Plate and the North American Plate slide past one another, creating a transform boundary through California called the San Andreas Fault. Along this boundary, the movement of the plates sometimes causes powerful earthquakes. The movement of the tectonic plates is driven by a process called slab pull and powerful currents of hot rock within Earth's mantle. Click the hotspots to learn more. Earth is hottest at its center and cooler near the surface. The rock in the mantle is heated from below. Hot magma is less dense than cooler magma, and so it slowly rises up into the upper layer of the mantle, called the asthenosphere. It then cools and falls again. This cycle of heating and cooling causes a rotating current called a convection current.
This is the best picture.
These convection currents in the asthenosphere move the tectonic plates in the lithosphere.
This is the best picture what they're showing, that how the currents, they come and they push and pull the and affect mantle, and then mantle affect the asthenosphere. It's very important, girls. Again,
Slab
show you about
Earth is hottest at its center and cooler near the surface. The rock in the mantle is heated from below. Hot magma is less dense than cooler magma, and so it slowly rises up into the upper layer of the mantle, called the asthenosphere. It then cools and falls again. This cycle of heating and cooling causes a rotating current called a convection current.
Let us see what is a slab pull.
Slab pull is a form of tectonic plate movement caused by differences in the density of parts of the lithosphere. Earth's lithosphere is made up of continental lithosphere, which makes up the land on Earth, and oceanic lithosphere, which is found under the oceans. Oceanic lithosphere is denser than continental lithosphere. When the edge of a plate that is made of oceanic lithosphere meets the edge of a plate made of continental lithosphere, it sinks beneath it into the asthenosphere, pulling the rest of the plate with it.
Now, girls, what is the major difference between slab pull and convection current? In slab pull, only the first layer of the earth crust, that is asthenosphere and lithosphere, involved. You're not, the mantle and the currents of the mountains are not involved here. Finally, with a ridge push.
Ridge push can occur at divergent boundaries. New crust.
When I am talking about the ridge push, it's exactly earth crust because of the divergent boundary.
is created at divergent boundaries from magma rising up and becoming lava, which cools into new rock. The process of ridge push is like two conveyor belts moving away from the ridge.
So this is how volcano occurs, because it is showing how the magma lava, it pushes to the both the divergent sides.
The plates move away from each other while new crust is being added to each side of the divergent boundary. The observation of matching continental coastlines was some of the earliest evidence that contributed to the development of the.
Okay. Which of the following is not true about tectonic plates? Girls, all about tectonic plates I have explained you. Plates are only made up of continents. Convection current help move plates. Plates subject into the asthenosphere. Mountains form along plate boundaries. What do you think is not true? At least, Judy, you can guess this. Mountains form along plate boundaries. Plates subject into the asthenosphere. Convection current help move plates. Plates are only made up of continents. Which one is false? What do you think? It could be the first one or third one. Choose one
One,
or third. Hmm?
the first one.
Very good.
Correct.
Tectonic plates are made up of Earth's crust, and the
They
ridge.
are not made up of continents. They are made up of earth crust, girls, and outer part of mantle.
Scientists use fossils. You have learned a lot about Earth's crust and how it moves. Before you finish, let's take a quick look at the main points you covered. Earth's crust is divided into tectonic plates. These plates are constantly moving because underneath, they are pulled by the processes of slab pull and ridge push. These forces are due to convection currents within Earth's mantle. The continents move because they are part of these moving plates. The continents move so slowly, we cannot observe their movement directly. Scientists have found evidence of their movement in their shapes. They seem to fit together like a giant puzzle. Across the continents, scientists have found similar fossils and rock formations, which show they were once joined together. As the plates move, they slide, grind, and bump against each other. The plates interact in different ways depending on the motion of the plates. At convergent boundaries, plates can crumple into each other, or one plate may slide under the other. In both cases, different types of mountains may form. At divergent boundaries, plates are pushed apart. And at transform boundaries, the plates slide past each other.
That's it for this lesson, girls. We have finished with plate tectonics. Do you have any questions?
No.
Okay, girls. How about math? Do you want me to explain, because I still have a few minutes? Any questions for math?
No.
No one? You all are very perfect in it. Everyone knows everything. Okay.
Yeah.
Nice day. Good luck. Practice very well.